Welcome to TechPacks, your partner in advanced research and development. In this video, we will be presenting the details about one of the most demanding research projects titled Hybrid Encoding and Clustering for Secure and Efficient Grid-Based Sensor Networks. This research project can be extended further to publish a research paper in a reputed journal or used for your PhD or MTech thesis. So, if you are a researcher, PhD, or MTech research scholar working on a similar research project and need expert guidance to handle the complexities of research in this field, you're in the right place. Watch this video till the end to gain valuable insights into the project's objectives, methodology, and results. We'll also provide a demo of the code in action, showcasing its key features and functionalities. So, let's begin. Our professional researcher will now take the lead and guide you through the details. Here we go.
Friends, welcome to TechPacks Research and Innovation Services. Today I'm here to present you one of the research area that is related to the secure communication in the sensor networks, either it is wireless sensor network or IoT sensor networks. So other than preserving the energy, there are certain other challenges in the current communication networks. So inspired from that, this research has been designed for the industrial purposes or for the research purposes. So before moving to the work, let's talk about that what we will cover into this video. In this video, initially we will discuss about in which application areas this domain can be implemented, where it can be realistically usable. Then we will talk about that whatever the code we have designed, how to execute it, what are the software and the library requirements, what cases we have discussed, all that stuff. Then we will discuss that what current systems were doing, what are the problems identified in them, and what is the proposed work that is given into this particular research work in order to handle those issues. And finally, an overview to the experimental outcomes and the findings will be discussed. So let's talk about the application areas. The sensor networks are not restricted to only wireless sensor network. It is currently very much attaining popularity in internet of things based domains. So it is either related to the smart home, smart transportation, smart cities, healthcare devices, agriculture, automation in the industries, and many other. So agriculture at the remote location by using the sensors in order to monitor the temperature, humidity, and other related factors. Smart homes where the fire detection or any temperature rise or when many other parameters can be designed by using these sensors. For the healthcare, like monitoring the patient at the remote location, secondly wearing the wearable devices to get the instant outcomes and the tracking of the health, and such many other applications. But other than that, we can also implement them the protocol that we have designed for the data security, because the data that we are transferring in the sensor network or the IoT, it is very crucial, and obviously no unauthorized person should be focus on this and can get the access to it. So data security is one of the application area where it can be implemented. Then network security, where the unauthorized person cannot access the data or the network communication route. So in order to handle that, this network security application is very best suitable domain for it. Also for a secure communication, where we need to use that the communication should be secure from one transmitter end to the receiver end. In that particular areas also, specifically for either WSN ad hoc networks or the Li-Fi networks, where the security is the main concern. So there this developed system can be easily implemented and can be used, because either we have used it for the WSN IoT, but the protocol that we have designed into it, it is not restricted to this only. That is basically related to the data. So obviously can be implemented in the different domains. So let's talk about the code. So the folder that we are going to provide you is like this. You just need to go to the code folder, and these are the different scenarios we have evaluated for the implementation. So in order to run the code, let's see, I am opening one of the code. These are the comparison scenarios. So comparison we will talk about later. Initially, whatever the code we have designed, the main codes are into these 5 folders. So every folder is having only the different scenario, but the basic fundamental and the process is quite similar. So in order to run this code, the code is having the subfolders. As you can see in the scenario 1, we do have two of the scenario in which the sync node is placed at the center, and one of another scenario is sync node is placed at the edge of the network. So let's talk about the center. So this whole code is implemented in the MATLAB. So in order to run this code, you must have the MATLAB software with you. So for MATLAB, we are using the MATLAB 2019. You can use 2015 or above in order to execute the code. So to run the code, you just need to go to the code folder and copy the path, and then go to the MATLAB, and there here in the bar you just need to paste it and press enter. When you will press enter, you will see the whole code whatever we have designed is here in the current folder. So the code to execute is code WC, code WOC, and comparison code. So these are three of the scenario in which we are initially analyzing the output, and secondly we are applying the optimization algorithm to handle the data. So this code is basically in to get the comparison and the simulation time and all that stuff in order to get the graph, right? So this is the code where the two of the scenarios that when we are applying the compression with the proposed method, and this is where we are not applying the compression, and finally we are doing the comparison among them that with and without compression how it is proving its outcome. So in order to run this code, you just need to click on the run button. When you will click on the run button, it will ask for the initially for the simulation time. Let's say I am entering 10 as a simulation time, and then I will press enter. Then it will ask me that which compression technique you want to implement. So here we have implemented uh, his Huffman encoding, RLE encoding, and we do have third option that is hybrid of RLE and AHE. So you can give the option by entering 1, 2, or 3 by your own. Let's say I am entering AHE, that is adaptive his Huffman encoding. So when press enter, then it will start processing, and the data which was generated here for 2000 count is applied with the technique name whichever we have selected, and whatever the size of the packet came out, which is passed to further simulation of the PSOGA based with the node count of 100. So it is simulating the results for number of times, because the simulation time is representing here the number of the times the code is to be executed. Then the average and the standard deviation results has been analyzed and shown into the output. So all the graphs has been given in the scenario, and finally the results will be there with us. So this is how the code is to be run. In the second scenario, we need not to enter any type of the compression, because it is directly by applying the results and getting the mean and the standard deviation results for the scenario. And finally we are comparing that whether the proposed methodology by applying the compression and encoding scheme it is working or not, else not. And this is the comparison for the different the leech, the PSO based model, PSOGA, that is the proposed methodology that we have given. So this is how the code is to be executed. So I'm just closing it right now. Let's talk about that what exactly the problem is and how we have overcome that. In many of the scenarios, the people are working on proposing the systems for the clustering as well as for the cluster head selection, but they are mainly focusing on handling working with the physical parameters like energy and distance only. But other than this, there are certain other factors those can affect the selection of the node. Like if you are selecting any node, it should be trustworthy, it should be secure for the communication. The next hop selection in the network is very crucial in order to provide the better outcomes and providing the higher packet delivery ratio. So even this can also help in reducing the delay factor and all. So inspired from that, we have proposed that the selection will be done on the basis of one of the more parameter, that is the security, which is calculated by using the trust factor. So that trust factor is basically the criteria in which the node's behavior in the previous communication rounds is considered for the further selection. Secondly, currently people are using optimization algorithm for the clustering or the clustered selection, but here we have implemented one of the technique name. Initially, one of the scenarios like applying the PSO, second is PSOGA. So PSO is applied in order to check that the cluster head selection over the different parameters. So the parameters that we are considering in the proposed scheme are like the nodes in the uh, communication area, because here the grid communication we have also applied. So the grid communication is the scenario. So where the nodes will be deployed uniformly in the network, and out of that every node should get enough chances to be a cluster head. So one of the contribution is uniformly deployment of the network. Secondly, dividing the network into the grid so that equidistribution should be there. Thirdly, the additional parameters has been used other than the physical, like security for the trust, in order to select the cluster head. Fourthly, in comparison to the traditional models, we are not applying the optimization algorithms to select the cluster head only. We are generating the weight values to the selection parameters, because weight based selection has been performed. So that contribution we have done. Fifthly, we have applied the normal PSO and a variant of PSO that is developed by us, that is PSO and GA's combination, in order to handle the issues those were faced by the PSO itself in exploring the new solutions. So that is the proposed methodology that we have done. So these are the major contributions that we have done. Other than that, we have explored it with the different scenarios where the different area, grid count, uh, and many other things has been done. The final and the major contribution of this work is like we are also handling the data. Instead of only focusing on the clustering or clustered selection, we are dealing with the data also, by applying the security to the data. One of the security part is like selecting the next hope with the trust factor. Second security is like we are applying the encoding scheme on the data, and also we have evaluated by applying the encryption and encoding scheme on the data. So the flow is like initially we are generating the data. That data is initially encoded by the encoded scheme, in which one of the scheme we have evaluated is advanced variant of Huffman encoding, that is adaptive Huffman encoding. Then RLE is evaluated, and we have proposed hybrid of RLE and AHE. After the compression, the data get compressed, and this encoded data is further encrypted by using ECC algorithm in one of our scenario. Then this encrypted data is passed to the network to transfer from one location to another, from nodes to the base station, by the proposed methodology of selecting the cluster head by the multi parameters, including the trust factor, and then weight values are extracted by initially the PSO, and secondly with the proposed PSO GA. Finally, the communication is being done, and the results are evaluated in terms of uh, alive nodes, dead nodes, energy, and many others. Like, so you can see it is taking too much time to evaluate the code. So I'm just waiting for it to be finished. So I just pause the code and rerunning it, as I only want to run it for one time. So I'm entering the simulation time as one and press enter. Okay. And the technique that I'm going to use is, let's see, with the adaptive Huffman encoding. One, press enter. Then it will start processing the code and will show the results. So we in the evaluation scenarios we have run it for a number of times so that we can get them. We can analyze the results in terms of the mean and the standard variation among the results for multiple runs, because every time the results will may vary because of the optimization algorithm. So that is the scenario that we have run it for the number of times. So now, but in order to show you, I'm running it for one time so that I can show you the results. Let's see that what we get here. After passing this is doing the compression as per the technique that we have passed. Then the data is passed to the PSO GA node 100. It means the function that is here, it is a scenario of the whole communication in the network with the 100 nodes and with the PSO and GA method. So let it be complete so that I can show you that the main code that we have designed into this. can see it is running for those many rounds of communication, which is a good score, but it can be decided only after having a look to the graphs, that whether we are actually getting the improvement or not. So the scenario that I am showing you is with the compression technique. Another we have implemented without compression, right? Means we are not handling the data in this scenario, and the overall work is being implemented into this, but encryption is still pending, because that is in the another folder that I'm going to show after this simulation. In the meantime it is running, let's talk about the another scenarios that we have implemented. So we were talking about the scenario one, under which the only variation is like, here you can see the only variation is the here the sink is at the center and here sink is outside the network. In the second scenario, we have applied the ECC encryption. So here you can see ECC encryption and decryption is there, which is applied after the compression. So I'm opening the code. I can open it in the notepad because the MATLAB is running. Here you can see, okay, it is done. So let's see the results. So tabular visualization might not be possible, so I'm just holding it. So it is on the line number this. So I'm just commenting the table. Right, so later on there is nothing, that is just to save the code. So all the results have been there. Here you can see the graphs are like, this is the alive node average and standard deviation, this is the variation, average dead nodes. So value is there for the one simulation, the results are there. Because it is only the one simulation, that is why it was not possible to show you the results. So we can run the comparison code directly, so they will show me the results which were already I think we need to run it for at least 2 times. Let it run on the backend. In the meantime, we will talk about the PSRE. This is the whole scenario where initially the adjacent tables, because the network that we are developing is for the grid based scenario. So this is the scenario with the 2 by 4 of the grid. Then the packets that we have transferred is the count of the packet which is achieved after the compression. So packet count, which was generally taken to be 2000 in the initial scenario, is now after the compression, whatever the size we got is passed to this function, and in this function that number of packets will be considered as the communication packets to transfer further. Then here the sync location is at the center, right? So then what we have done, we have calculated the trust factor. So here you can see the factor has been calculated, and many other parameters, including I can show you that which parameters we have considered into this: trust, hope count, S count, energy, power required for the communication, number of delayed packets, and the total packet received during the normal communication among the nodes. So all these factors are considered for the clustered selection. But in order to handle these much of the factors, we need the weight-based conditions. So the PSOGA optimization is algorithm is applied in order to get the best position. Those are basically the weight value for the factors. So these weight values has been passed to the fitness function in order to get the which route is best to communicate, and then on that we have the route is finalized. Then a communication has been applied among the nodes of those are there in the grid. So the grid that we are following is like, let me show you that how we are communicating in the network. This is the paint file that I'm opening for you. So let's say this is the network. So we just split the network into the grids. If it is 2 by 4, it means there are 2 rows and 4 columns. So that means it is like this. So there are 2 rows, one, this is 1, this is 2, and columns are 1, 2, 3, and 4. So we have defined that how node is to be communicate. For example, this grid has to communicate with the sink. So their adjacent nodes are grids are this, and this. So what it will do, it will choose the next hop either into this scenario, in this scenario, or in this scenario, so that the data can be transferred to the base station. If the base station is at the center, so it will check here it can be the base station, then it will transfer to either 2 or 3. So that what we have defined in the initial stage, that what grids are connected to which node. So for example, the 6 to the 2, 6 to the 2, 7 to the 4, 3, and 7 to the 3. So it means if it is 1, 2, 3, 4, 5, 6, 7, 8. So these are to be communicate among them, that which node will go, which data will send to which grid. This is how the grid communication we have performed and mentioned in the network. My code is still running, it is taking too much time, but still we need to wait in order to see the results. In the meantime, let's talk about the scenarios that we have implemented. Coming back to here we have applied the ECC encryption. Then this was for 2 by 4. This is for 4 by 4. And in this scenario, we are also considering one more energy, that is how much energy it will additionally take to compress the data, because the compression that we are applying, that is not considered in the scenario 1 and scenario 2. In the third scenario, we have considered the compression technique energy consumption by following this research paper, which is giving us the knowledge that how much energy is required by the wireless sensor network to compress any of the information. So this is the model that we are using, energy conservation by the data compression. So how much energy is dissipated, that is calculated from this. By taking this reference, we have added additional energy consumption in order to evaluate that whether our system will survive for the longer period or not. In next scenario, we have changed the grid count from 2 to 4. We have changed it to 4 by 4, so you can see rest of the code will be same, but we have not evaluated it for the like without or something. Here you can see it is only without compression and with compression. ECC encryption is applied only to the 2 by 4 scenario. The last scenario, we have applied it with the grid count of 10 by 10 and nodes of 625, 10 by 10 node of 12 by 50 scenario, right? So you can see we have achieved the results. Let's see what we got here. See, these are the average dead nodes. So it means the dead nodes starting from 2000 round and are getting stable up to 2700 rounds. So similarly for the alive nodes, this is for the average energy consumption. This is for the packet delivery ratio. This is for throughput, packet sent to base station. This is a standard deviation of the dead nodes, alive nodes, and all those parameters. Finally, how much time it took for the simulating first and second, it is in the seconds, so it is showing the results. So this is for 2 time run, right? So we have also saved the results for different scenarios and did the comparison, that you can see here in these areas. In the comparison, you just need to go to this folder, you just need to copy this. Let's see what we did in the comparison scenario. We have saved the results from those codes which I just showed you. Now you just need to open this code and you need to show the results. The results has been implemented and shown in the terms like because there were different scenarios when with AHE, with RLE, with hybrid of that. So in the comparison, we saved those results and showed it in the terms of the graphs. Like you can see 2 by 2 area, 100 nodes without compression, then with AHE, then with RLE, and then hybrid of RLE and AHE. You can see the hybrid of RLE and AHE gives us the better results in comparison to the previous methods, because data compression is more in this scenario. So you can see in every of the case, our proposed methodology is proving its effectiveness. So you can see the patterns for the standard deviation and the average results. So in this scenario, the results are good. This was for 2 by 4. Then second is 2 by 4 where the sink is at the edge. It is quite similar whatever the main codes are here. From these codes we have generated the mat file, saved and compared them in the separate folders. So then 4 by 4 on the center, 4 by 4 with the 200 nodes, 10 by 10 with 625 nodes on the center, 1250 nodes in 10 by 10 at the sink of the center. So these are the scenarios that we have developed and evaluated with the compression, encryption, proposed optimization algorithm, proposed compression technique in order to do the effective communication in the sensor network. So further modifications are still possible into it. So for getting those information, you can contact us directly and can get the details. Thank you. Thanks for watching the video.
Thank you for watching this video. We hope you found it informative and engaging. For more information about this research project and to get our consultancy services, click the link in the description below. At TechPacks, we offer comprehensive support for researchers, PhD, and MTech students in the fields of engineering and ICT. Our services include selection of research topic, helping you choose the right topic tailored to your interests and the latest trends. Synopsis preparation, crafting a clear and concise synopsis with well-defined objectives. Coding assistance, providing expert help with writing and optimizing code in various tools and platforms. Research paper writing, assisting in drafting and editing research papers to meet the highest academic standards. Dissertation writing, offering complete support for your dissertation, ensuring consistency and quality. Plagiarism check and removal, ensuring your work is original and free from plagiarism with advanced detection tools. We also offer customization services to meet your specific project needs. Whether you require a modification of an existing project or a completely new application, our team of experts is here to help. Don't forget to like, share, and subscribe to our channel for more updates on cutting-edge research projects and expert advice. Thank you for choosing TechPacks. We look forward to collaborating with you on your research journey.